Share screen. So Docker is widely used at this point, and it basically is, if you haven't heard of the term yet, it's containerization. It's the creation of containers for full-on applications. If you're familiar already with the concept of a virtual machine, it's essentially what a container is. So traditionally, if you're on Windows, hey, this is a great example, actually. If you're on Windows and you're using WSL, you're essentially running a virtual machine. You're running a Linux system inside of your Windows operating system. And Docker is very similar. When you use Docker, you can use it to create images, which are like snapshots of a local machine. And you can then run containers out of these images. And a container is basically like spinning up and turning on that machine. So the image is like when your computer is off. It's just there. Its files are still there. It's sitting there, but it's not actually running or doing anything. When you spin up a container, it's like powering that computer on. Now, there are many benefits to doing this, some being version control, let's say splitting up resources or being able to scale. So in addition to having just one container running from an image, you could actually create multiple containers out of an image. Let's say you were trying to load balance, for example. You have more traffic going to your server than you had expected. To scale, you would just instantiate a new container from that same image and route the next set of users to that container. Now, there are a lot of tools already in cloud services like AWS load balancing that essentially accomplishes this. But beneath that, there are containerization configurations, and Docker is one of the most widely used tools to accomplish that. Any questions so far? Awesome. Let's walk through what we're trying to do with the full stack that you've been working with so far. You basically have a client which allows users to interact with an API. That API is really being done right now through browser commands, through curl, through Postman. You then have a web server which hosts the client connection and interprets these API client interactions. And then you have an app server that routes the client server-side requests to the appropriate endpoints. And you have a database that manages the data and the interactions. Now, these different components have this flow, essentially. The client will send a request to the web server. Requests are sent to the API, and then those requests reach the database. The database then manipulates the data, and it sends the results back to the API, which sends it back to the client. Right now, the key problem with your application is that it's non-deployable. And this is where Dockerization comes in. You're running everything locally. So you'll have to give out your own IP address in order to get others to be able to connect to it. And that's not very secure. So what's the best thing to do is to run everything through a web server. And what I'll be demoing today will show how to utilize NginX to implement a very, very simple web server. NginX is an open source and readily available Docker image. You just go to Docker Hub. Let's take a look at that actually. Docker Hub will show you Oh no, it wants me to sign in. Let's see if I have an account. I don't know if I have an account, at least not with my Platoon account. Let's see if there's another way to search. Okay, cool. I can still search. Docker Hub allows you to search for existing images. And again, images are essentially snapshots of machine configurations and setups. So let's say similar to how when you're creating a Python app for a backend, you create a list of requirements in a requirements.txt. This file shows all the different dependencies that are required for this application to run. And then you just run pip install requirements.txt to install all those requirements. This is essentially what an image is. It's just a configuration and all the necessary files and dependencies to get the application to run. In today's demo, we're going to be using NginX. And so one way to pull this would be through a Docker command, docker pull NginX. Another would be to write everything into a Docker file, which I'll go over in a bit. This shows all the different versions and variations that you could use to set up your NginX container, and then some additional documentation on how to use this image. So we see here that we would have to use Docker run with a name of the container that you want to create. Like in this example, the name is some NginX, a path to an HTML file, a few flags, and the NginX command. Alternatively, you could write a simple Docker file like so. From NginX, you copy your local HTML and JavaScript files and CSS, if you'd like, into this path. This path is not a path on your local machine. This is a path that will be created inside the container. And once you run this command, Docker will do its magic and create a running instance of NginX. You could do some additional configurations like exposing a port and passing in more complex configurations, which we're not going to really cover. So let's go back to our slides and let's talk through how we're going to be setting this up. So we're going to be containerizing the front end web server using NginX to handle client requests. And we're going to do all of this through a very simple start all shell script. There's a repo that you'll be able to view, which will contain all the files. And basically, it's set up in a way that all you need to do is run this one single shell script. This shell script has 4 lines. And with these 4 lines, it will install everything you need to get this thing up and running. This very first command is /db/setup.sh. What that is it's going into a directory and running a setup.sh file. So if we look inside the people getter repository, you have your start all.shell script. It says to go into a database folder. And so let's go into that folder. This folder contains an init, a SQL file, another shell script, and a Docker file. Since we saw that it is running the shell script first, let's take a look at what's happening here. This shell script runs a Docker command to build a people database. It then runs another command, which creates a which runs the PG underscore database, and it passes in this flag that basically says, remove this entire container once it stops running. This -e is for exit. And then we pass in some params which include a password. I see. Okay, after this demonstration, I'll fork the repo over to codeplatoon.devops. Yeah, I think these were all taken from the Echo Platoon lessons. I don't think they were modified or anything. That's why you don't have access to this repo, but I will fork it over after this demo. So let's go back and there's a README that also goes over some of this. If you were to install this on your own, you'd basically just run this setup.sh file, but we have our Docker file doing that for us. So we saw that in that second shell script, it's running a Docker file. This Docker file says from the Postgres image, pull version 15 and copy this local file into this container destination. Everyone tracking so far? Any questions? Cool. So from here, we go to the next command in this parent shell script. It's running a Docker inspect. It's running this Docker inspect with these variables. So it's really pulling in from a range of network settings, the existing networks. It wants to pull in all the IP addresses from those networks, and then it's going to end that command. It's then going to pass all the information into the API /DB_IP_address file. So it's basically recording all of this information into a folder. And again, this folder exists inside the container. And I'll run through all of that inside of Docker Desktop in a sec. Once it's done with that, it then runs the next line, API /start_API.shell. So let's go back to our repository and let's see what that looks like. We go into our API folder, we now see more files. We have a startup script, which will again run the Docker build command, this time for the people_API. It's going to find that inside the API folder. It's then going to run, we see that remove command again, and it's going to define these ports, and it's going to call it people_API. Inside this Docker file, we're seeing from Python. So now it's pulling a Python image. If we were to go into our hub Docker, we could see that this is what's being installed. Specifically, version 3.11/Buster, wherever that is. It's then going to define a work directory, and that's going to be /source. And it's going to copy all of the requirements locally. So let's go back up one directory. We see that there's a requirements.txt file. It's got all the requirements we need to make this application run. We could see Flask here. Whoops. And then it's going to run pip install -r requirements, which should look very familiar to you. So it's doing everything that you would be doing locally yourself from the command line, all in one go. This is really just automation. And it then copies the additional files, server.py and the DP/IP address, which was created by the previous command, into the current directory. And then it runs these commands, Python server.py, which should also look familiar to you. These are commands that you run locally yourself from the command line. From there, we will then essentially have a running server. And then our parent shell script will go to the final line, front end, start front end.sh. So let's see what that looks like. Start front end.sh. Look at that. It runs another Docker file and it defines ports for that Docker file. In this Docker file, we are now pulling NginX, which actually I don't want to edit this one. We're going to change this version when I create a copy for you guys. The reason being, well, I'll explain it later. It's going to then copy some of these additional files into this directory, and that's really all it needs to do. NginX does the rest. The files that it's going to copy include an index.html template, which will really, it's just HTML to render the front end. So this is what you're going to see when you actually view the front end from your browser. And then it's also going to have some JS for some functionality. We could see here that we're going to be able to iterate through the database entries to create a drop down for you to view. It will be able to fetch, it will be able to get people, and these functions are going to work alongside what's defined in the HTML, where are the routes? I'm looking for the routes right now. Oh, they're right here, right? These URLs are the routes, basically. So once we have this running and we go into our browser, we could try these different routes and see the different results. And that's about it. Let's check this out. Let's see it in action. So I am now, did I already do this? I want to do this fresh. So here's my Docker desktop. I see that I'm not running anything. So this should be a fresh repository. I should have just pulled this before class started. So I'm going to run my start all.sh script. So I'm calling shell and I'm running the shell script. Or I should say, I should go into my directory first. Now I run this command. And now Docker is doing all of its magic. It's doing everything that we had just seen inside of our slides. Basically all of these commands. And once all of that is done, if we were to run the Docker PS command, Docker PS will show us all of our running containers. We see that we have 3 containers running. We have our people front end created 19 seconds ago. It's got a port of 80. And it's got this dynamically registered name, Elegant Feistel. And then we also have our people API is also running in its own separate container with a port of 8000. And then we have the actual people database running on port 5432. So let's see what this looks like. Let's see if we go to localhost, we have our front end. This is our front end that is being spun up by NginX. And if we run through this dropdown, we can see that we could actually see the data that was created in the people database. And did we look at, yeah, this is the same data that was initialized through this init SQL file. So basically, as you could see, Docker did everything we needed to do in just a matter of seconds. What am I doing? I'm going to close this. Here, I want to show you all of this as well. So now we could also go into localhost, pass in the port for our people API, and we could see a success message. And now if we were to add a separate URL, let's go back to our front end and look at our JavaScript. We see that we have different URLs for different functions. We have our getPerson function mapped to a URL where if we have the base URL and we pass in an ID, we should be able to get that person's information. So let's try it with Brant. So let's do localhost 8000/6. And now we have Brant's information. And if we go to the function above, we see that we could actually get all of the people with /all. And so let's see what that looks like. It's a little messy, but we see that we have an object containing all of our people, which is really a list of lists. So with that, let's take a look at this from the command line. There are other Docker commands we could run if we wanted to play around with the actual shell environments for some of these containers. We could use, for example, Docker exec to go into our front end container. So I'm going to grab this container ID. I'm going to delete that because I didn't mean to paste it yet. I'm going to pass in this IT flag. I can't remember off the top of my head what this stands for, but what I'm trying to do right now is essentially SSH into this container. And like I was saying earlier, containers are essentially like virtual machines. So right now I've got 3 containers and I've got my local environment. I'm in my local machine right now, but I want to get into one of my containers. I basically have 4 computers running in front of me right now. And the information I want to look at is inside one of these, but not the one that I'm currently in. So I'm going to run Docker exec, pass in this container ID, and then I'm going to run, let's say, bash so that I could see the bash environment. And you see how my username changed. I'm no longer JDCB on my local machine. I am root user at this container ID. Any questions? Does that make sense? Cool. So from here, I can now run other terminal commands. I could see that we have a lot of files, and I can run service NginX status to see the status of the NginX server. And let's exit out of here. Let's see what these other containers look like. Exit. It just froze on me. Oh, I see. No. I'll just exit out with Control-C because it wouldn't let me type anything. And now I'm going to do another Docker exec, but this time for my second container. And we see we are now root user inside of this container ID. We run our commands and we see that we can view the requirements.txt file and the server.py file that were moved over through one of the Docker files earlier, as well as the db IP_address that was created by the second line inside of our initial shell script. And now let's look at the last one. And same thing, we could see a bunch of folders, and let's see, what can we do? What can we do here? I think this is the Postgres database. So I could actually, now that I'm here, I can run commands like psql. I believe we're just going to do localhost, and the port number should be 5432. And my username, I believe, is Postgres. And just like that, I am now able to run Postgres commands. So if I were to do, what is it? L, \L, I could list all of the databases that are currently here. And we could see that we have our people database, and exit out of that. Whoops. Well, we can see that we have our people database. So any questions so far? I think that's about it for Docker. What you could do for the front end right now is, once I get this repository copied over to your organization, your GitHub organization, you could use the files inside of the front end folder to set up a front end inside of Flask, I believe. Does that make sense, Nick?
Sorry, what was that?
Well, if they're not going to go the route of using Docker to set up NginX, could they use this HTML file, app.js script, to set up a front end inside of Flask? I'm not very familiar with Flask.
I think it's just templates. So
Okay.
it's not like it's just straight HTML that can only be used. I don't think Flask can render like JavaScript.
Okay. So I mean, we could essentially just manually create a container to run NginX, but I don't know if Chandra wants to do that yet. So while you guys go back to working on your challenge, I'll play around with NginX and see if I could get that running locally outside of a container, and then we'll demo that. How does that sound? Cool. Any questions on Docker?
I feel like it was a lot of information, but for the basic understandings of what is used for, I think we kind of got the basics of the what is Docker is used for.
Awesome. That's good. That's good. Yeah, there will definitely be way more in-depth coverage later on. But I'm glad that you were able to see Docker in action and that it makes sense to you how all of it is working behind the scenes. So you'll probably also be using Docker Hub. So if memorizing command line terminal commands like Docker exec and stuff is a little hard for you, you could also use this GUI to navigate your containers as well. So let's say I wanted to look inside my front end terminal. Instead of using Docker exec, I can just use the front end to go into the terminal and run the very same commands. Service, NginX status. But again, all of this will be covered in more detail later on in the curriculum. For now, I'll let you all get back into your breakout rooms to work on your applications, and I'll see what I could do with getting up a local instance of NginX. Sound good?
Yes. Quick question.
Sure.
So I know some of us probably have already installed Docker, but for the people that haven't installed Docker into their system, do you recommend installing it into our desktop, or into our, let's say we're using, if you're a Windows user and you're using Ubuntu, do you want to install it in Ubuntu?
Yes, definitely install it in Ubuntu.
Oh, okay. Are you able to have both have one in the desktop and have one in Ubuntu, or is that going to conflict?
It's not going to conflict, but you're going to want to be careful as long as you're, like you're as long as you just remember where you install the containers. Like if you install a container inside of your Ubuntu system, it's not going to be accessible from your Windows Docker instance and vice versa.
Oh, okay. Okay, makes sense.
Cool.
After you fork that, can you drop a link?
Sure, I'll do that. I'll drop a link inside the Slack chat.
Sounds good. Thank you.
Yep. Okay. So setting up NginX, it really is pretty straightforward, thankfully. And we are really just going to use brew install to set up NginX locally. And when you're setting it up, you want to be mindful of what the logs are returning, because your default path for where NginX is set up may change, may be different from what I have, depending on how your homebrew is set up. So you will want to run brew install NginX, and
A lot of us are on Mac.
so what do you use on Windows?
Well, WSL, so it should be apt. I guess it should be apt install NginX, I think.
Okay, yeah, you could do that as well. The path might vary from how brew sets it up, but yes, either command works. You could use brew or you could use apt. Regardless of which way you go, you should, well, actually, I don't know about apt logging, but it should tell you what path your configuration is going to be installed in. Here we're seeing that mine is installed in this opt homebrew etc nginx directory. And then it also lets me know that there's a server's directory where nginx will load all of its files. So those are the key things to pay attention to. If you're using apt, this will not apply to you, but there are similar apt commands that you will use to do the same thing. You'll just basically want to be able to start, stop, and restart NginX, and also check to see if it is running. So if I were to run root services right now, whoops, I can see that my NginX errored out. Root services restart NginX. Root services. That is strange. I must have changed something somewhere. Anyway, before I start digging into that, what you're going to want to do once this is set up, well, is first confirm that it is running. So let's go to localhost port 8000. Or sorry, actually, I have mine by default set to 8080. So I have NginX running. I am able to see the default NginX page. Once you set up NginX, If you were to go into your NginX configuration, let's see, which for me is this right here. So code. You'll be able to see some very simple code and a configuration for servers. So here it's listening to port 8080 and it's set to localhost. You're going to do something similar inside this directory called servers. So I created a file called nginx-fe-demo, and similar to the server block in the other config, there's a listen. I've set mine to 8081, and you could ignore the server name because it doesn't matter for your local NginX instance. But you will want to change this root path. So this path is going to go to the HTML file that you want to use. So if you clone the repo that I'm going to push after this demo, you could cd into that directory, the front end directory where I've provided some of these files. And if you type pwd inside the command line, it will return the full path that you'll essentially want to use in this section here. Once you've pointed this configuration file to your index.html, you can close this out. And let's see how that looks. I'm going to go to port 8081. I may have to restart, or actually, this might be why. I wonder if this is why it's erroring out. So let's run a boost services again, see what is going on. Cool. It's like it's running, and now I am able to see people getter front end. And I am now able to also see all of my back end data. If you aren't able to see your back end data, it may be because you are using a separate port from what's defined inside the app.js by default. We can see the local host path here pointing to port 8000, which is where I have my API running. So if you can't see data, just make sure that wherever you have your API port set to, you set this line to point to that as well. Any questions? Cool. Let me get this repo up and I'll stop sharing.